Hi everybody, JJ here at Newegg Studios, and it's a pretty exciting day. We're going to be talking about a lot of really awesome Intel related hardware and a really, I think, an impressive platform across the board. It's the introduction of two flagship, really high performing processors, specifically the latest generation Skylake X series of CPUs. I've got an awesome cohort here from Intel to be able to go ahead and give us a deep dive into the architecture, performance oriented designs, and help to kind of fill in, I think, a lot of the questions that a lot of enthusiasts, content creation professionals, and anybody that's really interested in the highest end performance that the PC has to offer, we're going to hopefully fill in these questions. So Aaron, why don't you go ahead and introduce yourself?
Yeah, thanks, JJ. My name is Aaron McGavick. I am the strategic marketing and strategic planner for the enthusiast and performance pillar at Intel. And I'm excited to be here today with you, JJ.
Yeah, I'm very excited as well. I mean, this is, I think, been a long time coming in a lot of different ways. You know, when we talk about chipsets, platforms, CPUs, you know, we were talking a little bit off camera about really the length of time that it takes to really put in all the development so that we ultimately have a product like we do today in terms of these latest generation CPUs, as well as the motherboard. So this is, for all intents and purposes, kind of like the second wave to what really kicked off earlier in the year with the release of the X299 chipset, along with the Kaby Lake X series of CPUs, and then the first round of the Skylake X series of CPUs. So why don't you go ahead and give us a little bit of contrast in terms of now what we're looking at for this specific launch. What's new, essentially, right now on the 25th of September here?
Perfect. Thanks, JJ. Yeah. So we just introduced last night, we made the marketing announcement for our 16-core, that's the 7960X processor, and our flagship processor, which are 18-core 7980XE. Both of these processors have already set numerous world records. JJ, your Republic of Gamers overclocker has set 6 new world records and 16 global first place in the first 24 hours. And I think that's a remarkable statement that shows just how much the planning and product planning that we have put into it is now paying off.
Yeah, for sure. I think, and it also is an indicator to, I think, the inherent performance capabilities that this has. And so, to retouch a little bit as well on the CPU model, the CPU models that you went ahead and listed, is that when we talk about this, we're generally going to be prefacing, of course, with something like 16 core. But for these parts, they do feature essentially the hyper-threading technology. So we also, for those of you who might be wondering about the total thread count, right? We have essentially just want to multiply that times 2, and you're talking about a huge amount of essentially processing capabilities. And I think one of the most interesting things that we're going to hopefully get into here and help you guys understand is that it's really not just about the total number of quote-unquote cores or threads here, right? Architecturally, there's a huge amount that you guys have really baked in, and this is one of the things that we were talking about that I think make the platform and the architecture so compelling to not only, of course, you know, content creation professionals and prosumers, but also, you know, to megatasters, to gamers, and to overclockers, because there's really a lot of diverse technology that's been baked into it, label a lot of really interesting flexibility to really be able to offer the highest level of performance, right?
Yeah, correct. And just like you had said, there was a lot of planning that went into this, the product development of this, and we take a lot of feedback from the enthusiast community. We try to incorporate that into our next series of processor families and designs, and try to bring that to market for you. And just as JJ said, this is Intel's first teraflop processor as well. What a tremendous direction that we've been heading. To think that 20 years ago, when the first teraflop supercomputer came out, it filled a room. And now we have one sitting right here in front of us that fills no more than an eATX chassis space. It's quite incredible.
It's extremely incredible when you talk about just the performance, and it's also, I think, right in line with, if we look at the usage model for a lot of the users that they can benefit from, it's really coming at a great time, right? We're seeing more and more applications that are, of course, becoming multi-thread aware, right? At the same time, you've got architectural implementations that help to benefit those legacy applications that are still only running on single threads. We've got huge improvements in terms of bandwidth capability, and then, you know, the platform as a whole in terms of helping to supplement all the responsiveness that we need from storage and so many other pieces. So I think one of the most important things always is to create a little bit of kind of compare and contrast. From Intel's kind of positioning, you guys, of course, have a mainstream chipset, and then you have a high-end chipset. Why don't you give a little bit of insight into kind of just recapping what fundamentally we see from the difference on the mainstream chipset to this high-end chipset, and specifically where these kind of CPUs separate themselves from what has been already released?
Okay, perfect. Great question. Fantastic question. I know a lot of folks out there are interested. Why should I buy an X299 chipset-based system over, say, a Z270-based system? At Intel, we try to fill every single market need that is out there. And for some folks, they want a great gaming experience, and they want a very streamlined application service that they can look at and run. And with that, the regular client space is probably a real good place to start. There's the prosumer and the content creator and the extreme gaming systems that do require, just as JJ said, more I/O, more capabilities, and larger processing capabilities. And so that's where the X299 platform starts. Now, we had received some feedback earlier that folks would like more entry-level points. So we came out with the Kaby Lake X processor line, which is our client silicon that's been placed into the Socket 266 package and is available for the X299 system. And that basically starts off the X299 platform. And then from there, we work up adding cores and adding capabilities until we reach our flagship product, which is sitting in front of me here, the i9 7980XE, which has 18 cores, 36 threads, and is a tremendous powerhouse processor.
Yeah, and that's really impressive. I mean, there's never been anything really like this before in terms available, I think, to the PC DIY enthusiast, right? I mean, when you fundamentally talk about that, you can go from a 4-core part all the way up to an 18-core part. That's a huge amount of range, and so especially within, I think, these platforms where we see that traditionally users tend to have about a 3 to 5 year cycle in terms of the ownership, and they also tend to I think, have a little bit more of an incremental philosophy on upgrading memory to higher density channels, or adding in additional add-in cards, or upgrading the processor, or of course looking to more expansive overclocking pursuits, right? The platform has been really purpose-built for this, right?
Yes, correct, yeah. So folks that may have gotten into the X299 platform with the idea that perhaps they might expand at a later or future point, they have the capability to do so and to add the necessary I/O, memory, and other options that they need as they migrate up that stack.
So in terms of just some generalized technologies, let's take a look at some stuff before we get into some of the architectural things, which I think are interesting. Of course, all the CPUs, of course, all support PCI Express Gen 3. So if you're coming over from an older related chipset, you're going to get that latest PCI signaling speeds, right? You've got, of course, support for the latest I/O specifications, things like USB 3.1 that's baked in terms of the chipset. You're going to, of course, have support for DDR4, but DDR4 is interesting, right? Because this is now your second generation memory technology, the second generation memory controller, which has really been quite impressive when we take a look at the mainstream chipset, right? Where an X99 is that first generation quad channel memory controller. It was very impressive. I mean, huge amount of bandwidth, monster numbers, but of course when we talked about the frequency, it was a bit more conservative, right? What we saw compared. But you guys have been able to leverage a lot of that work and that optimization. Same thing from a motherboard perspective. We've been able to take all that optimization, that work that we've done with you guys, to be able to implement some very impressive quad channel memory performance. I mean, it's a significant increase compared to X99.
Correct, yeah. I think my home system, my X99 that I had at home, topped out about 3,200 megahertz for my overclock. And 3866 is not a problem with XMP memory on the X299.
Yeah, and
plug that right in, it just works.
Yeah, and I think, and that's one of the things that I think we'll talk about a bit more here is trying to hopefully have a greater sense that the platform really, you want to try to look at all the different aspects to it. So while I'd say conservatively, of course, within the mainstream memory, mainstream gaming space, memory bandwidth is important. It does play a factor in terms of performance, but it's not as critical as, let's say, the CPU clock frequency, right? Where CPU clock frequency is king, and having a really fast part, like the 7700K, it's fantastic for gaming. But if you're running 2400, 2666, it's fine. You not necessarily see a huge uptick if you go to 3200. But when you go into more professional applications where they're actively swapping in using large amounts of memory, being able to go up to significantly higher bandwidth all of a sudden is in addition, in terms of that performance uplift that you're also getting with the increase in terms of the IPC. So when we talk about IPC, we're talking those instructions per clock, essentially the architecture inherently, the clock speed advantage. So it's all a combination of giving you that further performance. So I think that it is important to kind of discuss and help to understand, because some people might not necessarily realize I'm looking at the CPU, but that CPU, because the memory controller is built in there, is also going to be affected by being able to put faster performing memory with greater compatibility, right? As a whole too, most people may not realize, but the vast majority of memory that enthusiasts are going to buy, you go to Newegg and you sort through your memory, almost all of it is XMP based. Correct. And for those that don't know, XMP was actually initiated by Intel. It's the extreme memory profile. Yep. So all of these have really been purpose built first and foremost for an Intel chipset to run on an Intel memory controller. And so when you talk about plug and play interoperability and compatibility, you get that best experience.
Correct. Yeah.
So we've got the second generation DDR4 memory controller. All the SKUs are unlocked, including, of course, these two new SKUs. They support overclocking. We've got new instruction set support, right? Why don't you fill us a little bit on the instruction set? Because for some people, I think they don't necessarily think about instruction sets when they consider, I guess, a new CPU.
Yeah. So several generations ago, we introduced a feature called Advanced Vector Extensions, AVX. And part of that, we've grown the capability of AVX from an initial 128-bit processing capability now to AVX 512. And so basically, the amount of AVX instructions that this processor can process per clock cycle is now quadrupled over where it was before.
Right, and so, you know, from kind of face value, we can use that traditional analogy that gets used a lot when we talk about bandwidth, but it's like going over, you know, from a single lane highway to, you know, like a 4-lane highway, right? We've opened up a huge amount of bandwidth to allow for a significant increase in terms of that instruction computation capability. And this is, I think, kind of like, I wouldn't say an ace in the sleeve, but it's kind of like almost you're going to get performance for free, essentially, when these applications begin to code this in over time. So right now, for the vast majority of gamers, they won't see a benefit from this because games don't generally leverage AVX instructions. But if you're a user of, let's say, applications like Premiere, Premiere has AVX instruction set support built into it, like many content creation applications. And so this is one of the things that if users on that prosumer or that professional side of the fence adopt in, not only are they going to get the, you know, generation to generation uplifts from, you know, new IPC, higher clock speeds, overclocking, more DRAM bandwidth, but they could be, you know, getting a significant upgrade from just the AVX instruction sets alone when those get phased in over time.
Correct. It's future-proofing for when that next instruction set gets incorporated in those apps. Yeah.
And I know from some discussions with some of the team members that we've had on our end, discussion with Intel team, you guys have actually a content creation team that's also in discussion with these software development companies to help to progress to try to implement this. So it's also a question of, you know, some people might wonder, it's like chicken before the egg kind of scenario, right? But you guys are actively helping to have these software developers be aware of these type of technologies so that they can get improved upon, right?
That's correct. Intel has a whole division actually called SSG, Software Solutions Group, and their purpose is to go out and help enable third-party solutions and third-party software vendors to incorporate all of our new features and help streamline those so that as these new products come to market, that the software is there to help support them.
Cool. So when we get back to, I think, the kind of the pure performance aspect of this processor, there's a lot of interesting parts here, right? So one, we know that we've got general IPC performance, right? So if we compare this to, let's say, the previous generation X99 platform, just before we get into, of course, a lot of the other optimizations, what's the general kind of IPC uplift or the general kind of generation to generation uplift that you would see?
That's a fantastic point. So because of the enhancements that we've made inherently in the architecture, as well as the enhancements we've made on the monolithic die to help speed inter-core communication, we're seeing anywhere between 6 and 10% IPC instruction improvement sets at the same clock speed.
Yeah, and so that's quite impressive when they consider that also, of course, you can easily start to uplift this more, like I said, by adding in faster DRAM, of course, the overclocking capabilities, and then, of course, when we start to talk about things like turbo boost technology, you guys have baked in speed shift, which is also something that hasn't really been that talked about. It's something that you guys first rolled out in the mobile your guys' mobile product offering, but many people don't realize that this is a new technology that had to do with responsiveness. It's a bit harder to test for, but it also is really in line with you guys baking in technologies that align with, I guess, the real-world usage models, right? It's about trying to dynamically have that processor be as responsive in terms of coming up to those clock speeds as quickly as possible. Can you give some insight?
Correct. Yeah. So our prior method of speed shift technology was based on software, and so we would wait for Windows to send a response back to the processor saying that, hey, I need a faster P state or a faster frequency to run at. Now that took some time and some latency in order for that to happen. What we've done with speed shift or hardware P states is we've enabled the hardware itself to recognize when those workloads are being asked on the processor and to respond. It's a factor of 10 faster. Yeah,
it's a significant reduction in the latency. So to give you guys a little bit more clarity exactly what we're really talking about here is that when that processor is operating at a lower frequency, let's take for instance that if the processor is idling, right? So you're sitting there at the desktop and let's say it's, 1.2 gigahertz or whatever that base value is, and it needs to boost up to, let's say 3.6 gigahertz or whatever it might be. So we're talking that period in its ability to go from that idle frequency, right, to that much higher frequency is now much more dynamic, much quicker, correct? And so that's another way that you see that, especially from workloads, the way that people work, you might be shifting from your browser, jumping into your editor, maybe then jumping into a different application. Having that type of responsiveness also leads to just an overall quicker, better experience for your system.
That's correct.
And that's an exclusive technology that we see in these new generation CPUs, right? So it's not something that's just conditionally within the operating system. Like I said, it's on a hardware level.
Yeah, correct.
So now I think kind of going past that, one I think the most other interesting aspects is that there's been a lot of discussion as we start to enter into, I think, these really big core counts. About kind of overall the design of the CPU, right?
Yeah.
The package and things along those lines. And so your guys' approach is very interesting because traditionally and for quite some time, and it was quite revolutionary when you guys introduced really the ring bus architecture, right? It was about optimizing performance and efficiency. But why don't you give us some insight into the transition, because we're now not looking at any longer at a ring bus, right? We are looking at something entirely new that you guys call a mesh architecture, but it aligns with your guys' pursuit to want to have low latency, better performance, and also efficiency, right? I mean, there's a lot of talk about there's no escaping that these are going to be much higher power requirement parts compared to the mainstream, right? But still at the same time, you want to find that balance of trying to be efficient at handling thermal dissipation and power requirements.
Yeah,
right?
correct. Okay, so to attach that first question, so we went from the ring to the mesh architecture. As the number of cores on the ring expanded, there was greater latency incurred, right? Even with 4 memory channels stationed throughout the ring, with an 18-core processor, you could have several hops through cores before you get out to the integrated memory controller. With the mesh, and having the distance is greatly, or the number of hops is greatly reduced, thereby reducing the latency. We chose to still do a monolithic die rather than a bunch of core complexes or multi-chip packages, because it reduces that latency and allows a greater control over the power processing between all of the cores. We can balance, just like you said, the power and also the thermals as the part becomes more and more used, versus relying on the coherency between multiple chips on a package, which maybe we don't have enough control over.
And two other benefits, I guess, would also be here is that one, your voltage efficiency, because you have less hops, right, within a ring, is that allows you to maintain a tighter, lower overall voltage, so you get better efficiency. But also this affects overclocking. Your choice of a more monolithic type of die design, right, is allowing essentially for greater pursuits in terms of frequency. So why don't you give a little bit of context into that, because I think one of the really big strengths that we have is that traditionally as you get into higher core counts, you are going to generally look at a degraded CPU frequency ceiling, right? But as we've seen from not only the world record performance that we were able to achieve on our latest ROG ASUS X299 series boards and these CPUs, that the overclocking capability is actually still quite impressive. And we're seeing frequencies that are fairly actually similar to that of what we see within the mainstream series, especially when we look at per core tuning.
Yeah. So I quickly glanced before this meeting, because since we just released this product last night, basically, most of the reviewers online are seeing air overclocks of somewhere in the 4.5 gigahertz range with 18 core, all cores. And just to speak to your point, by choosing that monolithic die, we are able to get a better control over the cores that are on that die.
Right.
On a wafer itself, cores can either be slow and less leaky, which means they use less power and are more apt for low power or mobile usage, or they can be fast and leaky, which is great for overclocking. It does consume slightly higher power, but
it
being
opens
able
up
to
that headroom.
But yes, being able to have that headroom on all of the cores on that die by picking those nice fast and leaky die allows for the best experience for the end user. Now, to also hit your point, once we keep going up in core count, one of those cores on the die may be a slower core, right? Not quite as good as some of the others. And so that's where the new technology we introduced on the Broadwell family comes in. Intel Turbo Boost Max technology 3.0 picks the best cores off the die and gives you additional performance headroom by utilizing the cores that are the fastest.
And the great thing is
we'll
that
see that later.
that's an automatic overclock. So while the CPU itself has overclocking capabilities that can be manually induced by the user, so you can go in and you could use like our automated auto tuning technology to have it dynamically increase this frequency, apply voltage, and do kind of traditional overclocking. This is essentially overclocking that the processor will do by itself. It will detect the workload, and essentially based on that workload, it will attempt to automatically scale up to, what's the peak frequency, 4.2?
For on this actual product, the turbo frequency, single core turbo is 4.2. The turbo boost max frequency for up to 2 cores is 4.4 gigahertz.
So it's a pretty aggressive, and it shows you exactly what you're talking about in terms of that architecture complementing the workload. So while we've got a huge, very multi-threaded centric based design, right, that's going to complement those type of workloads, we still also have a processor design that's really at home within a large amount of the applications, whether you're talking about browsers, games, even many more basic type of editing applications, which are only lightly threaded.
Yeah, correct. Yeah, and to your point, it's not quite, I want to carefully term this, it's not quite overclocking, right? So we are running those 2 cores faster. They are not running outside of any
right,
of the specs.
Right, correct, yes. It's
it's
within your guys' defined envelope of life expectancy of all operating parameters.
Yeah, so basically if you were to look at it, the worst core, if it were to hit that frequency of turbo, would require a certain voltage.
Correct.
So at 4.2 gigahertz, let's just say it's 1.2 volts. Now, some of the other cores on that die that may be faster and more efficient, they at 1.2 volts may be able to run at 4.4.
Exactly.
And so it's the same voltage that would normally be applied to all the other cores. It's just we're getting more frequency out of those.
And that actually brings us into the next point, which is actually overclocking itself. So one of the biggest pursuits that we've had, and I know that we worked at length with a lot of your performance team to be able to bake in a lot of technologies that you guys were putting on the CPU side, and we wanted to bake into our board design in terms of our UEFI, our BIOS design, was taking advantage of a lot of hooks and knobs and switches, like impressive stuff like when you guys did decoupling for the buses, right? When you guys started adding in the ability to have different types of options at how you could adjust multiplier adjustments, right? So when we talk about overclocking in general, one really big strength is you guys is that this is something that we've been working on for an extensive life cycle, right? I mean, we're literally talking at this point, we could probably go back, I think in the technology sets that are in play, probably about 5 to 7 years, have been progressively getting more and more refined. And if we talk about overclocking, many users right now might purposely look at something like what's called an all-core overclock, which is the kind of the traditional old school type of overclocking where they would take every single core and they would fix it at one single frequency. But to what you just spoke about is then you might be leaving megahertz on the floor because not all the cores are made equal. And so a benefit that you guys have specifically in this architecture, which isn't something you see right now on some other platforms, is going to be the ability to have per core overclocking.
That's correct.
So can you give some context into this? This is something that we've discussed, I know, at length with our users. Even our automated auto-tuning technology actually uses per core overclocking by default. We don't pursue a fixed manual overclock because it limits the total frequency that we can get out of the CPU. So we want to give users the best performance. But why don't you give some people some insight into the exact specifics of the difference between a manual and a per core overclock?
Awesome. Yeah, and I really like this question because I think a lot of the enthusiasts out there are wondering what other benefits are out there, and there's a hidden benefit that most folks haven't quite latched onto, and that is if you download our Intel Turbo Boost Max Technology 3.0, it's a long title, driver, and you run it, and we'll run that in a little bit and show you how that works, you will get a list of cores. And they're not just some static generated list. Those cores are listed in order of their, the best core to the worst core. I'll leave it at that. The core that runs at the highest frequency at the lowest voltage is listed first, and it's followed all the way down. And you can use that as a hint. And that hint will allow you to do per core overclocking to perhaps a much greater level. Like on the processor we're going to be looking at, we already looked at which one was the best. Core 13 is the best. You may, in your BIOS, be able to overclock Core 13 an additional 200 megahertz. Because at the same stock frequency, we know that it runs 200 megahertz faster.
Exactly. And so to give you guys a context of how this might really play out, and these are just approximations, because of course, keep in mind, with every CPU, there is some difference, right? There's maybe a consistency. I would feel pretty comfortable in saying, pretty much any 90, 7980XE, you're probably going to be able to do a 4.2, maybe in a 4.3 across all cores, probably for the vast majority of them. But as you start to get more aggressive, there's going to, of course, be some variance, right? But as an example might be maybe on one thread, you might do like 4.6, maybe 4.7 gigahertz. Maybe if you had a really amazing CPU, and then maybe you drop down, right? On 2, you might be looking at 4.6, then maybe you go to 4.5, then like 4.4, and then you've got 4.3 or 4.2. So this is a bit of a different approach. It does require a little bit more kind of tuning, but I think this is also speaks to the time and effort. These are not easy things to implement. There was a lot of time and effort that was put on not only ASUS parts, but definitely on all the effort that Intel's engineering team to be able to give this type of granularity and control to the user to be able to define all these type of options, right?
Yeah, and going back to your other point too, when we went to the mesh architecture, one of the benefits that we incorporated at that time, you remember with the ring architecture, we had what was called the uncore, which was basically all the I/O and the memory controllers and everything that wasn't a CPU core. With the mesh architecture, we're able to decouple the DMI clock.
Which is fantastic, because
the
then
memory
you don't
clock
have to worry about it.
Yeah, so now instead of overclocking or overvolting the whole uncore ring, now you can specifically choose perhaps the buses that you wish to overclock.
Right, and even for this generation, there's even more specificity, right? Like you can do voltage per even core, right? So there's levels of granularity here. For some of you guys, it might be just like, wow, I didn't even know these type of options. But I think that's what we're trying to also help to show you, that while you're going to see a lot of information that will help to show you great performance. Unquestionably, I think when you look at clock-to-clock performance and all the popular synthetics, you're going to see outstanding performance for this part. But there's a lot more that meets the road as you begin to look into how you can tune this platform, how you can tune this CPU to even be able to extend performance further and further. So another part that I think goes directly into this, we talked about manual overclocking, per-core overclocking, core ratio adjustments, all these kind of different options is, and I think we have maybe some screenshots that we can show of some of these options for people so they can kind of see to some degree what some of these options might be. Is voltage is something that doesn't necessarily also get talked about, I think, as consistently, but it's actually quite important because, again, there's architectural designs that you guys have put in terms of how you can control, right? And so for most users, they generally have approached overclocking with something that internally generally gets preferenced as like a static or a manual voltage. And what this means for most of you guys that are probably familiar is it's a fixed voltage. It means that it doesn't matter if the CPU clock frequency goes down or the CPU clock frequency goes up. If you dial in something like 1.35 volts, it's going to be 1.35 volts continually. The disadvantage of that, though, is of course it means we're producing more heat, we're consuming more power, we have higher probability for voltage degradation over time. It works. It's a proven method, but it's not necessarily the most efficient method, right? So what now has come beyond that is offset. Offset has been around for a very long period of time, but offset kind of had some challenges. It was a little bit more complicated in terms that you would add incremental voltage levels as you increase the CPU frequency, but it wasn't necessarily always super elegant because it was still influencing our, let's say, our stock range, right? And then adaptive came about a little while ago, and to me, it was what I termed as almost the holy grail of overclocking voltage control, because it meant and I'd love to hear your guys' insight in terms of this, but fundamentally, really, it allowed you to not influence the operating characteristics of the CPU under stock parameters, and really only target giving more voltage when you were actually, quote unquote, overclocking the CPU.
Correct.
So give some insight there.
And you can see we've actually pulled up your BIOS options within the UEFI shell to show that. And you're right. We introduced, we have what we call per core voltage control and per core P state control. And that was introduced on the server architecture back in the Haswell timeframe. So that's been around for this is the third generation now for the high-end desktop SKUs. We have yet to introduce that on the client. And I'm not going to comment about future products, but it's something that we are looking at.
Yeah.
So with that, though, it gives you the options now to have individual control over the voltage and frequency of each of those cores. Not only as we go through the stock operational frequency of that, optimizing the power that you're using for the frequency that you're getting, but we can extend that up into the overclocking range intelligently so that your overclock doesn't stress out your part over time as greatly, because voltage is the biggest killer of silicon degradation. But it also allows us to do it power efficiently. When you're trying to cool a part, you know, it's helpful to have the other parts to be at basically a P state that's idle, while the other ones are doing their work.
Yeah. So I mean, and so you know, really, again, what this guys is hopefully helping you understand, and really what it means is that when you define, let's say, your overclock pursuit of, let's say, you know, that 4.2, 4.3, whatever that frequency is beyond that stock, is that you're really only having that processor work far less in terms of its overall wear over time, because you're more effectively being able to manage how you're actually driving that voltage. And before I think we get to one of the next parts, voltage outliers I think is also quite impressive, is that when you look at the frequency ranges of what you guys are hitting, right, in real world situations, you know, I think you know, it's fantastic to be able to talk to our guys in the ROG performance labs when they're doing stuff on liquid nitrogen, liquid helium. But for the vast majority of real users, they're doing what we have right here. They've got, you know, 240 millimeter, 360 millimeter, maybe a custom water cooling type of setup, but they're using more traditional types of cooling type of configurations. But one of the things that I was most impressed by is, you know, even looking at, you know, the 16 core and the 18 core part, you were hitting, even at, let's say, the entry points of like 4 gigahertz, 4.1, pretty conservative voltage markers, right? I mean, you're not talking 1.4 volts.
No,
you're not even talking 1.3 volts. So why don't you give some insight into that? Because I think that's also great for those people that kind of have a concern of like, wow, I don't necessarily want to be hammering that. And when you combine that together with being able to use something like an adaptive voltage, it's a really great combination.
Agreed, agreed. So to your point, yes, we are the Skylake architecture based on, you know, the client-based architecture showed really good power to voltage correlation, right? So as we upped the frequencies, we were actually able to gain a lot of frequency before we had to have the hockey stick in voltage. And so it's very apparent even on these processors that you can have a significant amount of overclocking headroom, just as the reviewers have seen 4.5 gigahertz on anywhere from 1.2 to 1.3 volts. I mean, that's really low before you start getting into the range where the voltage has to creep up quite a bit. For
right, yeah. When you're starting to push it more, you're definitely going to have to give more. And I do want to preface it that, you know, again, while it's extremely impressive and these levels are quite impressive in terms of what's capable, especially when you're considering the sheer number of cores and the frequencies that you're driving. You know, this is where it's a combination in terms of making sure that you get a great CPU, but you also look at a great board. You know, like we did a lot of work to work on optimized VRM designs, having, you know, we have specialized dual power connections that even have thicker gauge wiring to minimize resistance, right? Because we're talking, you know, pretty sizable amount of current, you know, that you're pulling through. You know, there are definitely factors. So it is still a combination that as you look at the entirety of your system, you know, the selection of what you can consider from your you know, your power supply to your motherboard, your cooling solution, you want to make sure that it's aptly in vein to be able to make sure that you're not limiting yourself in ensuring long-term reliability.
Correct. That's very important when you're making a choice on motherboards as well as power supplies. We're in a space where a lot of folks in the past we're kind of used to the 10 and 8 cores, and as things got more and more efficient, power supplies came down in size. And so it's important, as we've gone to a 80% greater core count than we had in the last generation, that we're going to be pushing some greater power usage models. And so perhaps the power supply sizing needs to be one of the first, and the delivery system, right, the VRM system on the motherboard, needs to be robust enough to support what you're intending to overclock.
Yeah, and also even the P states and C states, right? I mean, sometimes if users are bringing sometimes these older power supplies, it might be a great power supply. They might not necessarily realize maybe the power supply is a bit degraded, so it's not operating at that peak level of performance. There also might not necessarily support certain C states. Some users sometimes aren't aware that newer power supplies have been specifically rated for these deeper C states because there's a lot of power optimization that you guys have baked into the CPUs. The operating system now has baked in. So, you know, sometimes when we see people feedback issues on things like sleep and hibernation, it can be indicative because they might have kind of rolled over an old power supply or might be using something pre-existing. So, you know, just make sure to take the time to evaluate the entire component chain to make sure that, you know, everything's up to snuff to give yourself a great experience. You don't want to make an investment in a really great CPU and short yourself on the power supply, the motherboard, or one of those other components. So that gives us some perspective. We talked about architecture, we talked about overclocking capability, improved DRAM, instruction set support. That in itself is already a lot of stuff, right? But there's also some other really impressive things on the platform as a whole, right? And I think this is something that's interesting. So when people talk about a motherboard, usually they kind of preface, okay, when they're building a system, they're prefacing, okay, here's my CPU, and there's my chipset. And they think about the core chipset, maybe like the number of PCI Express lanes that the CPU, along with maybe the PCH will give them, and then maybe the base I/O. But they're not necessarily factoring in other elements. And with Intel, there's actually quite a bit of other things that fill out kind of the prospective platform experience. So one is you guys, of course, help define Thunderbolt, right,
Correct.
in terms of specification. And this is an exclusive technology right now on this high-end platform. So for users that are interested in this, you have the latest generation USB 3.1 and Thunderbolt spec.
Correct.
Right? And so that is something that you won't have on other high-end platforms. Beyond that, of course, you guys have rolled out the Intel Optane technology, and that's also something that's exclusive to this platform. And another one following along with storage, and I think it's really interesting, we can show here a card that we'll be releasing shortly, but is Intel VROC, right?
Yeah.
So I think this also speaks again to when you guys are trying to design the entirety of the platform experience, right? Each one of the things within a system influences the performance, right? So storage, we definitely know, is a big effector to performance. CPU is a big effector. DRAMs can be a big effector. So why don't you give us some insight in terms of actually VROC and how it plays into X299 and the CPUs in terms of the PCI Express lanes and how this ultimately, why is it a big benefit, I guess, ultimately to users that have the most demanding storage workloads?
The perfect question, yeah. So when we first came out with the X299 chipset, we intended for it to be VROC capable. We've been working through a lot of the validation and the testing that's necessary to enable VROC on the CPU. For those that aren't familiar, VROC is virtual RAID on CPU. Or on controller, right? So basically what we're looking at is the ability to RAID your NVMe storage off of the PCI Express lanes on the CPU and to boot from them.
Yeah, and that's right there is a big one because right now that's exclusive to an Intel platform, is a bootable NVMe-based solution. It's not otherwise available. And traditionally when users have gone through a traditional RAID, unless they're using, of course, some specialized type of add-in controller, is that it's generally gone through the DMI bus. The challenge that you have there is though that has its own fixed bandwidth, right? So if you took some pretty high performance SSDs, you pretty much hit a wall. Usually about 3 SSDs, you would saturate the pipe and you wouldn't get any more performance. But the big benefit here is that essentially you're telling us we can bypass all that. We get lower latency, and we get a huge increase in the bandwidth, right?
Huge.
So if you take a look here at this Hyper M.2 card that we'll be releasing that'll be compatible with all of our X299 series boards that offer, because of course all of them offer VROC, you can see we're going to be able to interface 4 PCI Express NVMe SSDs. So when you talk about users that are out there, and we're talking about really, I'd say, the true professionals out there that have the most demanding workloads. People that are working in medium format photography, people that are in that, 30, 40, 50 megapixel photography. They're doing heavy batch conversions, raw processing. 4K uncompressed RAW, 5K, 6K, 8K workflows, you're going to be able to throw all this video out there and the system's not going to be holding you back because you've got just gobs of bandwidth and gobs of performance. So it's a very impressive technology. I mean, at the same time, it will be an expense, right, to be able to put in that much storage that's high speed, but it's in line with the total performance that the system is enabling.
Correct, and it's the usage model that end users are looking for, right? So if you are a content creator, myself at home, I'm part content creator as well, and having the ability to scrub that timeline in excess of the regular RAM system memory that you have in your processor and then go to your large scratch drive, which could potentially be 4 M.2 cards all on RAID, that is amazing, right? To have the preview capability that you normally would have to wait for stuff to get loaded into the system, processed, and then loaded into memory so you could scrub. Huge benefits.
Yeah.
And to speak back on VROC, right, we officially came out with support today for RAID 0, 1, 5, and 10.
So that's actually quite nice because not only are you guys giving a performance benefit, but you guys also are building in options for people that are looking for more security and redundancy as well. Yeah, so that's quite impressive. I mean, I think totality, when then you look at the platform as a whole, right? There's actually quite a bit here, right? It's not just the introduction of just these extremely high performance overclock enabled CPUs, right? But there's a lot of other aspects that really allow for more flexibility, more functionality, and a better overall, I think, system experience for a user that are building their systems.
Yeah, no, I completely agree. And I think that, having the next tier of storage being able to keep up with the massive amounts of core count that we're enabling will go a long way for end users to have that experience for what they're looking for.
Yeah.
I mean, I hate sitting there and waiting for my regular SSDs just to load stuff up on a timeline.
Right.
This just allows that to be 10x faster.
And I do think one preface point that for those that are wondering is that at least for VROC, at least at this time though, it is limited to your guys' highest performing M.2 Intel-based solutions, correct?
Correct, right now, yep.
Okay. So overall, I think some pretty impressive stuff there. So I think one of the next things here we want to maybe take a look at is giving some more insight specifically into the Turbo Boost 3.0 technology.
Sure.
So I think for those of you who are not familiar, this is one of the most interesting questions, actually most common questions I get when I build systems is, what are the actual drivers that you install, and is there a right order? And so for Turbo Boost, there's actually a specific driver that does need to be installed. Once that driver is actually installed, there is a corresponding utility, and this brings up what you were talking about, where it gives you the ability to assign essentially the affinity, that prioritization to an actual application. And so here in the run-through that we want to be able to show you guys, we've done it with Cinebench, right?
Yeah, correct.
So why don't you go ahead and give some insight into what we're going to be showing.
Yeah, no problem. I'll explain a little bit more about Intel Turbo Boost Max technology 3.0, because again, it's not your normal turbo.
Yeah.
We first introduced this product, or this feature, on Broadwell. For a high-end desktop, it was enabled on our best core, the one core on the processor. For the Skylake i7, i9 platform, for most of the processors, enabled on 2 cores.
Yep.
So you get 2 cores, 4 threads that are enabled. And in the past, like we had mentioned earlier, the single core turbo rate would be determined by the worst core on the processor, right? So if you had one slow core, that would determine the cap for how fast single core turbo could go. Now we realized that having a lot of cores to pick from would allow us to have a better odds of getting a couple of good ones. And so for Skylake X, we're picking the 2 best cores off of that die, and it shows a marked increase in frequency support. Now you can run this if you have Windows 10, anything after Anniversary Edition. The driver to support this is native and built into the operating system. However, it does not offer you the ability to control which app that benefit resides on. So if you're in the middle of doing an important task and your virus scan kicks off, then the virus scan may get the benefit because it's asking for the most CPU performance. If you go online, though, to intel.com and download our Intel Turbo Boost Max Technology 3.0 driver, then you have the ability to do several things. One of which is to pin a specific app so that it alone receives the benefit. And you can select a bunch, there's a whitelist, and you can simply drag and drop the apps that you want to receive the benefit in that priority order into the tool. So what we've done here is we've done a static run of Cinebench, and I've tried to do it on a single core so that we could see a really easy percentage benefit from running it with Turbo Boost Max off and with Turbo Boost Max on. So we did a screen capture because it takes a little while to accomplish the benchmark. You can see that the score is about 184 Cinebench units for our i9-7980XE processor, which would be running at 4.2 gigahertz. So that single core is running at 4.2. Obviously, with a score of 184. Now I'm going to kick it off by opening Cinebench again and opening our Turbo Boost Max driver and enabling the app and the foreground app to have priority. And then we will run this benchmark again while we talk about it. And you can see the difference. Now what's going to happen in this benchmark is that single core is going to then process instead on the best core, or one of the 2 best cores on that processor, which now runs at 4.4 gigahertz. So you should see a 5% score improvement on the benchmark score for Cinebench as this runs. And this works for every single application on this CPU. If you have a lightly threaded application, it's going to direct that workload first. If you're just running the native Windows implementation, it's going to direct that workload to those best cores first, and thereby accomplishing your tasks relative 5% or so faster than it would if you were running it on, say, a part that did not have Turbo Boost Max and still running at that same frequency.
And I think this is where also what was most impressive, and one of the things I really saw was amazing with this generation with X299 and Skylake X, was this was how you also were fundamentally able, when we first saw it with like the 7900X, to be able to really bridge that divide of historically the mainstream chipset always had that bit of advantage where it was the better kind of single-threaded performance, but you guys were almost pretty much able to hit that parity. So it was really starting to get that best of both worlds where you truly were getting amazing single-thread performance. I don't even want to say amazing because it was already great. Yeah. It's just, it was finally able to match what you were seeing within the mainstream sector of 7700K type class CPU, but then you still got all the other benefits of more cache and more cores and more PCI Express lanes and all those other things. So it was quite a bit of a, I think, impressive implementation to be able to offer this.
I agree. This is us listening to the enthusiast community, right? People came back and they said, hey, I have to make a choice between a very fast 4-core part, or I could spend $1,000 at the time and get an 8-core part, but in my single-threaded apps, your $340 part was so much faster. Right. And so I have to make this decision because I have I do some things that require lots and lots of cores, right, but then I also do some lightly threaded apps, and I don't want to have the best of one world on one processor and the best of another on another. So we took that to heart, and we tried to no longer have any penalties for right, owning the part with the most cores.
And that's really impressive. I mean, because again, we go back to something like an Adobe workflow, is that this is entirely normal for many users. They're working in Lightroom to do all their photography, right? Mm-hmm. And it's a single-threaded, lightly threaded application. But then the moment they were jumping into Premiere, many of those things can fully benefit. I've done some, actually, I did a build with actually the 7960X with David Dugdale, content creator, and we were seeing from his previous generation overclock 4.3 system, there were performance increases that were in the 50 to 60% range, yeah, because of course the increase in cores, the architectural IPC improvements. So it's a great balance of that. Now you get really those best of both worlds scenario. And then of course, when we still talk about the fact that you've got unlocked capability here, yeah, you're just starting to kind of go into the spectrum, right? This is all where we talk about where, hey, maybe you drop in your 3866 memory, mm-hmm, right? You start to do some of that per core tuning, right? And then you're just even talking about bigger and bigger uplifts in terms of the overall performance.
Yeah, that's correct. I don't want to interrupt this build, but when it gets done, I'll pull up that core list. And just as we talked about earlier, that's the hint of which cores on your CPU are the most likely to overclock even higher. Right, so those two favored cores are going to be listed first, and then the rest of the cores in their core order are listed below that. And so as you do your core by core tuning, it is those can be a very strong hint as yep, to which processors or which cores on the processor have a much better capability of getting a higher frequency.
Yeah, and for those of you, I mean, I think it'll be finishing up just about here in a moment. Yep. For those of you that still have that bit of kind of reservation, we still have maintained our auto tuning technology in all of our X299 series boards. And so we actually have already implemented the support for the actual quote-unquote favorite cores. So we will do a full per core tuning technology in real time. You can target by temperature, you can target by voltage, you can target by clock frequency, and we will dynamically do all those things for you. We'll even enable XMP profiles for you up to a certain frequency so that, because of course by default when you put in your memory, even if it's XMP, it doesn't enable that clock speed. So we've tried to, I think, through a combination of leveraging your guys' work, give you a great balance of being able to get the best performance, whether you want to do it manually, whether you want to do it very simply and easily and effectively automatically. The choice is really up to you. But let's take a look here at these scores.
So it's finished, yeah. So in our previous run, if you noted, it was a score of 184. Now with this turned on, we expect it to be roughly 5% better. And there's going to be some run-to-run variation.
Right.
But
it's par for the course,
yep,
right? It's
but
benchmarking.
But you're seeing a score of 192, and that's aligned with what we're looking at. So a score of 8 points better on 184, which is roughly, I don't know what, 3%. Yeah. So you run to run, there'll be a little bit of variation, but you can see that just by clicking a couple boxes and directing the workload towards that single core, yep, you can have a significant throughput increase on your part.
Yeah, it's a very, very, very cool implementation. So overall, again, I think it helps to just show that the granularity and control of this truly being an enthusiast platform, it's resounding, I think, in the work. When you begin to really kind of dive into all the levels of granularity and control that are possible, they have definitely been there so that, like you said, you've listened to the community, we've collected that feedback, we've worked with Intel, and there's a huge amount of these options that are present there to allow you to really try to maximize the best performance possible based on your workload. Because at the end of the day, that's the thing that you're going to find that will be challenging. You'll take a look at a lot of different reviews, and it's awesome. We've worked closely with reviewers in the same way Intel has to be able to make sure that they have hopefully the best experience possible to show you the benefits. But ultimately, there's a huge amount of varied workloads that are out there. And so really what you want to go is that nobody knows their workload better than you yourself. So you want to begin to look at and see what is the tendency for your applications. Are they leveraging sensitivity to DRAM? Are they leveraging sensitivities to lightly threaded clock speeds? Are they leveraging sensitivities to higher core counts? And then that begins to help to fill in the landscape of, one, the breadth and depth that you guys have on that CPU range, right? Again, going all the way down from that 4-core part all the way to an 18 port, you've got a huge amount of options that there's going to be a CPU that will work for you in that right scenario. In the same way that we have, boards that start off with, still great overclocking, great fan controls, great audio design, all the great things that you want in a good board from the entry. But as you move up, you get more supplemental features, more functionality, in the same way that you scale up within the CPUs.
Yeah, correct. And I just was going to pull up the core list. So part of the Turbo Boost Max application that you can download from Intel.com does the core ordering for you. You can see in this instantiation that on this particular part, your 2 best cores on the part that are going to be receiving the Turbo Boost Max benefit are cores 13 and 7. And from the specs of the part, 4.2 gigahertz is where the single-threaded turbo locks out. So that means that core 9 down at the bottom, as your slowest core on the die, is roughly 200 megahertz delta from core 13. And so as you do your individual overclocking, you can scale that up, knowing that at the same voltage, at stock frequencies,
you should be able, you have
there's a 200 megahertz delta.
Yeah, and that in itself is, just huge. I go back to just years ago, and I go, I wish I would have had that type of information.
You have to iterate all the way through every core. I remember having to tune it on Haswell. I was trying to get the most overclock out of my part, and it was just painful because you'd shut down. You have to try, this core, and then this core, and then you weren't sure which cores were being correlated because they'd reorder them all. And your overclock wouldn't be stable. This is a nice, easy way to create a stable overclock that's personalized or individualized for your specific CPU.
And you will even see this information as well for the kind of the super manual tweakers that want to do it. If you do go into the UEFI, it is also listed within the UEFI environment, so it is visible in that respect as well. So from here, I think we've covered a pretty good breadth and depth, I think, to the architecture, to the platform, some of the overclocking capabilities and functionality. So we'll see, maybe we've got any questions that might have come in. And then, of course, I know that one of the most common things is, you of course have spent a huge amount of time with this platform. It might be interesting to talk about maybe some of the considerations about how users should go about approaching building this, because there are, I think, some different considerations for when you talk about building for this type of platform as opposed to building for, let's say, like a mainstream Z270 type class system.
No, I think that'd be a great set of topics. There's 2 questions that have come in online. The first one is from Leo Peril. Hopefully I'm saying that right. Or sorry, not Leo, that's the person in the back. It's from user Han Solo with a Z. That's pretty cool. And it's from YouTube. And it says, will the 8700K be compatible with the Z170 chipset? So I wish I could answer that question on a forward-looking basis, but 8700K is our Coffee Lake part. And so I can't comment on the compatibility for future products. So I apologize, but I can't answer that one for you.
What I would say, for that is that, that once those products are officially launched, there's always an extensive QVL. So the easiest way is if you want to verify that, if you go to, ASUS.com, once those products are available to the market, we have a very clearly defined CPU list that lists not only if there's previous generation or whatever it might be, they're all listed. So you always want to verify that that part is listed there. If you don't see it's listed there, then it's not compatible.
Okay, perfect. Second question is from Nadi Maruko. It says, so what kind of availability are we going to have on a wide range of RAM? A list of RAM we can utilize with the new CPU without any issues. And that's a fantastic question.
Very good question.
So as part of the XMP spec, we help to go out and with the memory vendors and define a specification that allows XMP rated memory to work seamlessly with our parts. Now, it does come down to signal and board integrity. ASUS has great signal and board integrity, and so there are other factors that issue into that. But XMP memory in general should boot up and run at that rated speed, so long as they're adhering to the XMP spec with our CPUs.
Yeah, as a whole, you're generally going to find that really for many of the top tier manufacturers, whether you're talking about here, we've actually got some really nice memory. This is from Team Group. This is their Nighthawk. It's Delta RGB. RGB DIMMs tend to be a little bit more conservative in terms of their peak frequency. These are rated for 3200, which is still quite a big uptick compared from X299, especially when you talk about higher density configurations that you're able to run, 3200 even in full 64 gig 8-DIMM configurations, right, and even more than that. I would say based on our analysis, this board we have here is validated actually for 4200 speeds, which is quite aggressive in terms of quad channel population. But really, I would say, like you said, if it's an XMP 2.0 certified kit, it's on the QVL, I don't really think that in most situations you have to be concerned that you're going to run into having to find a right part. And it'd be interesting to see your experience. From us as a board vendor, well, I will preface something is that we do recommend that we caution users that when they're buying kits, try to target making sure that what you're purchasing is actually not just an XMP 2.0, but it's actually a quad channel native kit. Some users sometimes will buy dual channel kits and they'll double up on them. But the challenge that you have with that is that we can do everything right. Intel has a great memory controller that's been optimized and all these things. But specifically, for memory, you have three factors. One is frequency, one is timing, and the other is voltage. And when you usually have dual channel kits, some of the timings, especially some of the sub-timings which are a little bit tighter, tend to be different in a dual channel versus in a quad channel configuration. So we get people that'll they'll pop in these two dual channel kits, they'll enable XMP, and maybe there might be an issue. We do some auto negotiation to try to make this a little bit easier for users, and many times we can be successful, but sometimes it may require you to have to manually tune something. And the easiest way that you can make sure to not run into that issue is buying a full native quad channel memory kit. And this does also even extend that if you get a 4-DIMM quad channel kit and you even got later on another 4-DIMM quad channel kit, that you'd still potentially have to factor that in because it's different between 8 DIMMs versus 2 DIMMs.
Yes.
So there are a little bit of subtleties, but as a whole, the memory compatibility on this platform compared to other for quad channel platforms is outstanding. I mean, it's really just about every active memory kit right now is validated as an XMP module.
Yeah, I would wholeheartedly agree with every comment, right? My personal home system has an 8-DIMM kit. You need to get some from the same batch, right?
Yep.
So they test these things as they come out. Sometimes there's batch-to-batch variations. So you buy the kit that's recommended, the quad-channel kit or the 8-channel kit, and don't try to put together ones even from different time periods, because as processes mature, things kind of drift.
Yeah, and some vendors do a little bit better job than this. What you can sometimes check is if there is a version number that sometimes is listed on the memory module, because sometimes the memory manufacturers will keep the same part number, same part name, but it might be a different memory IC. So you just want to be kind of cautious of those things. It's a little bit tricky, but for the most part, that's why if you buy really where your target is initially, you really shouldn't expect any overall issues in the long term.
Correct, and I think there's pretty wide availability of those high-frequency DDR kits out there. Newegg has quite a few.
Oh, yeah,
I looked just before I came. I just did purchase 3866
for
my
now.
home system. They're widely available.
Yeah, and I would say also that's probably about where I would also preface that there's I think a reasonable cutoff, because of course as you also start to scale in, you definitely have the possibility that the Intel memory controller unquestionably is the de facto standard. If you're talking about the fastest memory speeds that are possible, you guys have set the bar for amazing clock speed performance, not only in dual channel, but also in quad channel. But there is also, as you get into the highest frequencies, there is a little bit of variance in that the memory controllers built in the CPU needs to be able to support running at that speed as well. So some of those absolute most aggressive kits, like you jump into like 4200 or something like that, it could be 100% validated, the board could be validated, but there could be some margin. So you do want to consider that. Where I think the sweet spot really is in that 32 to probably about 3866 range. It's a lot of bandwidth, a lot of memory to play with.
Yep, and your memory timings still stay pretty tight too.
Yep.
Question again from same user. So he says, are we going to see a new 8-core Coffee Lake CPU? I should read these beforehand. That we can run on the new motherboards that will run the 8K series of CPUs coming out later. Unfortunately, again, I can't comment on the number of core counts or Coffee Lake in general. So when that product launches, I'm sure we'll be back.
Right. I think, though, what we can reaffirm, though, is that Intel, in terms of the hierarchy, though, the X series chipset is your flagship series chipset.
Correct.
It is going to offer the most expansion and performance possible for users that are looking for the highest level of multi-thread performance.
That's correct.
Yeah.
That's correct. User Gavin Fuentes from YouTube, it says, what's virtualization like on X299? Intel has always had good support. And that support has not deteriorated at all, Gavin. I think Intel does offer best-in-class virtualization from everything from virtualized I/O all the way up to CPU resources. The Skylake X part is derived from at least the HCC die that we're using in this one, high core count die, the 18 core, is directly derived from our scalable workstation and scalable server parts. So virtualization on the CPU is fantastic. It's been validated, obviously, to run on our server parts, and so I would expect that you will have the same great support that you've always had.
I love that question too. I think not enough enthusiasts do virtual
yeah,
boxes.
Virtualize, I know.
I love it because I run a virtual sandbox for my operating system. All my drivers, all my patches, all go first through a virtualized environment before they go into my real OS, so that if I run into a problem with something there, it happens there, and once I go into my normal OS, I don't have to worry about it.
Yep.
So it's fantastic to know that you don't take a massive performance penalty. There's always, of course, a little bit of a trade-off there, but the performance that you have, especially with this type of platform, it's really impressive.
That's what I was just going to say. With the memory capacity and the I/O capabilities, and now with the storage capabilities.
Yep. It literally feels like you're working.
Yeah.
It feels like you're in quote unquote your legitimate real OS. So very, very cool stuff there.
Yeah. So I don't have any other questions. Please keep the questions rolling in. Not about future products, but anything about X299, we'll answer those. But back to your point on how to build a good X299 system, or what we need to look for.
Yeah. So from our end, I think one of the most common questions is people ask about. What are the differences on kind of the motherboard side? I think very similar to you guys have a very expensive CPU product stack, and so sometimes there's questions of like, well, what's the right motherboard to pick? And I think very similar to Intel's philosophy, like right now, every single CPU is enabled for unlock support. They're all essentially can be overclocked. They all offer those same type of tuning architecture capabilities in terms of adaptive offsets, the AVX imports. Oh, we actually, before we get into that, there was one that we forgot to talk about, and I thought it was really, really cool feature that's exclusive also to this Intel platform, is AVX offsets.
Oh, sorry, yep.
So let's take a screenshot of this. So this is something that a lot of you guys, probably many of you, have never heard about. But again, we talked about some applications use AVX instructions. But what you find out in the real world is these applications, when they do use the instruction sets, are significantly more taxing. They produce more demanding loads. They use more of the overall quote-unquote CPU, really, and they produce also more heat. And so what you can find is that in the pursuit of performance tuning in terms of overclocking, an overclock that, let's say, is for maybe a game or for a non-AVX instruction application will be entirely fine at that frequency. So let's say as a target, we say that's 4.6 gigahertz, right? But the moment we would jump into an AVX loaded application, it would not be stable. And so historically, this kind of meant that I had to then bring down my total overall overclock at the expense of the applications that were fine and fully stable running with that instruction set. But here, we actually now have an AVX offset.
Yep.
And so this is super cool. I'm geeking out a little bit, but it's really, really nice, because essentially what it allows us to do is selectively adjust the multiplier, so the ratio for the CPU, and we can reduce it so that when an AVX instruction workload kicks in, we can reduce that. So if, let's say, it was 45, well, the moment we go into that AVX application, we can drop down to like 43.
Yep.
So then that way we 100% make sure that we maintain stability as our paramount focus. So this is, again, really tailored towards, I think, the prosumer, the content creation professional, somebody that wants to make sure, even maybe a streamer or something like that, switching over an application where I want to make sure my system's always stable, right? But I'm still also trying to ride that maximum level of performance, right?
Correct. And we saw that, right? So as more of the processor gets exercised, it can operate closer and closer to the rated TDP of the part. Yeah. In the overclock segment, right, that increase in temperature demands can cause a part to go unstable.
Yeah.
And before it wasn't ruining overclocks, but it would cause some instability that could potentially lead to a blue screen.
Yeah, for most general users, it wouldn't really be a factor. Like I said, It would be really, it's more for those professional users where they were going a little bit more aggressive.
Yeah, exactly. And that was only in the overclock space, not during regular operation. But
Correct.
What this does is built into the processor stock, if you were to purchase the stock rate, there's a built-in AVX offset already into the processor. So if it's in turbo mode and you run an AVX workload, the part will automatically downclock at stock frequencies to keep the part stable and keep it within the TDP envelope that's the part's rated for. In the overclocking segment, though, like you said, we saw instability, and what we have offered here is the ability to do an offset so that when you do overclock, that processor will downshift accordingly. And it's also per core enabled.
Yep, that's even the sweeter part. Yeah, it's
exactly.
continue to be refined.
So you can still, just as you have the ability to set ratios individually for each core, you can also set an instruction set or a negative offset for AVX on a per core basis, thereby allowing you the most control over your overclock.
Yeah, like if we went into the UEFI right now and you went to this option, for some it might seem daunting, but it's really amazing for the users that want this granularity, because you'll see literally the entire list and you can just go in and steadily adjust that. And even on ASUS boards, we've even run even further with some of this, and we have our what we call our temperature target control tuning parameters, where we can also conditionally play with the frequency based on target temperature goals within the UEFI. So when you want to target in even saying, I know this application always keeps me underneath 60 degrees. Well, can I get another 200 megahertz because I'm at a much cooler point, right? So just really, really, really cool stuff. But moving back now to our kind of build narrative, one of the most common things people ask about is just looking at that board, what makes the most sense? And for us, at least, ASUS's design philosophy has been that we try to make sure that there's non-negotiable. So it doesn't matter whether you're buying our entry -A series board or something like what we have in this system, which is our flagship. This is our Rampage 6 Extreme, or we have our Apex board or a Deluxe series. Really, the differentiation you're going to find is that it's about trying to complement, I think, the highest level of what Intel might offer. So, an example, if you buy something like, the 7960X or 7980XE, you might be in that situation where you might benefit more from having the U.2 connector, more SATA ports, more USB 3.1. You want 811 AC, you want 811 AD, you want dual NICs on the board, right? Where the -A will actually generally offer about the same overclocking capability. The heatsinks might be a little bit more basic, so you might still want to account for thermals in the same way, like, if you have a 240 millimeter through a 360 millimeter cooling solution. They're both still very good coolers, but one has a little bit lower overall consistent temperature, right? So it's similar in that regard, where higher end board with maybe a two-stage heatsink has an overall lower operating VRM temperature compared to maybe the more basic heatsink that's on that board. But overall, what we talk about from power delivery design, the topology for the DRAM, all those things we want to maintain a consistent experience. So when you pick the board, don't worry about picking a board based on that one board's going to offer a significantly better experience in terms of stability, compatibility. It comes down to, I'd say, your usage model and your expansion, and then also your aesthetics. I think this platform is definitely first and foremost for the most demanding prosumers, professionals, content creators, gamers that also probably are doing content creation and streaming, things along those lines. We definitely have tried to define an aesthetic that offers users a lot of choice in terms of having really great looking systems. As you can see here within our build, we've got a nice synced RGB vibe, but for some users, they might just turn all the LEDs off and want a clean blackout build. But from you, what do you think are some of the overlooked aspects when you take a look at building a higher end platform like this, where I know we talked a little bit about power supplies, but where are some other areas that you think people should pay attention to? Yeah,
well, I think we touched on it as well. Some of the X299 board series that are specifically built for content creation will have 8 DIMM slots, right? We're still a quad channel processor on our i9 series. And as such, we support 4 and 8 DIMM configurations. But some of the X299 boards, either because of a form factor limitation or because of other limitations, they come with 4 DIMMs. So a consideration may be, well, what type of DIMM density do I want for the total capacity I'm going to be using in my platform? And you can choose accordingly.
Yeah, and that's a great point too, because that might be something that initially it might not necessarily be something that you think about, but if you're upgrading over time, that does play into things, right? Because it's easier to, of course, drop in additional memory if you want to go to higher density. But there are boards, say for instance, when we have something like our Apex series where we drop down, it's because maybe we're trying to maximize maybe more frequency, right? So you still want quad channel, but we're trying to target less DIMMs so that we can go to higher clock speeds. So it's all a balancing act, and we all also finally entering an era where even with 4 DIMMs, we can have 64 gig configurations, which is just quite nice in terms of that. But if you're a really demanding user, then of course you really want to look at that 8 DIMM configuration for the most memory.
A couple questions from the internet.
Sure.
On builds.
On the maximum though, what is right now quote-unquote memory limitation for the memory controller in terms of density target?
So that's a fantastic question. Our supported memory configurations right now go up to 128 gigabytes. That's what you're going to be able to buy off the shelf.
Correct. In
Now,
terms of
as-
current.
Yeah, as memory generations evolve, then support may increase accordingly.
Okay.
Yeah, it's what's been validated. We can only validate.
Of course,
what's
what you
being
have in
produced.
hand. Yeah, I mean, it's very similar. X79, at the very end of X79 lifecycle, there was the kind of theoretical aspect the memory controller could do 128. We'd actually validate at the very end, we did release UEFI releases that allowed for 128 gig DIMM support. So, you know, it's a very future-oriented platform in that respect.
Yep, there'll be future expansion as technologies evolve.
Yep.
2 questions on builds, actually, from the internet. So one comes from Gavin Fuentes again. He says, JJ, for a new PC, should I buy a DAC or use the new audio features on some higher-end ASUS boards?
That's a really good question. It's a really common one. So take, for instance, this board. It does actually have a pretty nice isolated audio design. It's what we call Supreme Effects. So our goal really there is it has a high-quality codec. So it's a Realtek's latest 1220 audio codec. And the challenge that you, of course, have is you got a whole bunch of electrical items on the board that influence the operating characteristics of that codec. And so the goal is when we started to design that audio implementation was saying, what is affecting that? And if this is its peak level of performance, can we essentially try to ensure that the peak level of performance stays at what it's maximum rated at, and not what was the case in the past, which is that, okay, maybe it can operate up to potentially 120 dB, but in reality, it's significantly under that because it's got so much interference and all these other factors. And what I will say to most users, with ROG boards, definitely, if you're looking at them, they do offer a bit of a higher end level of performance because they will feature generally dual operational amplifiers and a DAC. So we have worked with ESS to put in a DAC that gives you better post-processing, better clarity, better soundstage. Now, while audio can be really subjective, there are hard measurements. We do use very high-end audio precision equipment. Goes through an extensive, actually, analysis process to make sure that unquestionably we are giving you better performance in all the key measurement aspects. And in things like volume range, it's going to inherently allow for greater, louder volume ranges. As far as whether that's going to be, let's say, better than a DAC, an isolated DAC or even our own high-end discrete sound cards will still offer a better experience. I will say that for my kind of general rule of thumb is that if you've got headsets up to about $100, $125, the integrated audio experience is quite good. The operational amplifier can drive it really well, opens up the soundstage, gives you really good tonality. If you start to go into that marker, you know, I've got a couple of pretty nice planar magnetic headphones that cost me, you know, upwards of $600 plus $100. That you're going to generally want to go with, you know, like a discrete dedicated sound card, maybe an amp, maybe dedicated DAC, that choice. So I'd say go in that general marker. If you're $150 and under, or you've got, you know, monitors in that regard in terms of your speakers, then you're going to get a great sound experience. And if you go beyond that, then you're going to probably still want to look at a discrete type of sound card.
Yep. Perfect. Means I have to upgrade my headset. I'm still on the old 5.1. The other question comes from Hamden, and he says, JJ, which case and fan vendor should I aim for that's 100% Aura, so for the RGBs compatible? I don't like having different programs for lighting, and I'd like for every LED to be controlled by the Aura software.
Yeah, no, that's a really good question. So for those of you not familiar, ASUS has worked on what we call our Aura initiative. So RGB lighting has become a big trend. We were the first board vendor implemented on boards, and we have the most expansive portfolio. So in this test system, you can see here, the motherboard has integrated lighting. These fans actually I have RGB Aura control, and the memory also. So these are ASUS Venom series fans. So these actually are fully Aura compatible. The great thing is that means the fan header connects to a traditional 4-pin fan header on the motherboard, and then they have a actual standard 4-pin Aura header that I run into an actually ASUS RGB splitter. So that splitter will connect to one of the 2 RGB headers on this board, and then I can connect multiple fans to that. And the great thing that means is that I can go into the Aura software and everything is fully synced. As far as vendors, Fantex right now has actually a really great set of options. Like I said, I really like these ASUS fans, and they have the splitters available. But if you want to go for trying to go with something inclusive, Deepcool is doing a lot of stuff. They have chassis, coolers. They have upcoming fans that will be released shortly. Enermax is also a partner that has chassis, coolers, and fans that are going to be coming out. Silverstone and Fantex actually have a very interesting design, which they use actually fan grills. So instead of having to get an RGB or a fan, if you've already made the investment in a nice black fan, white fan, neutral fan that you already have, you can buy a lower cost just fan grill. You put it in front of that, and that will link in with our board. And that will allow you to go ahead and have Aura-centric control. And you can actually go directly, if you search for ASUS Aura, if you search that in a browser, you can actually go to our Aura microsite where we actually have all our Aura partners validated there. So a lot of choices to pick from.
Fantastic. And that's all the questions we have here. But going back to our PC build, some of the other areas that I would recommend looking at, right? We talked earlier about, hey, we just went from the Broadwell generation of parts, which had 10 cores for their maximum in the 6850. We went all the way up now to 18 cores, an 80% increase.
Yeah.
And so a lot of folks from a power supply and power subsystem delivery, as well as a cooling solution.
For sure, cooling.
They may need to rethink some of the options that they have. I personally like to reuse most of my coolers.
Yep.
And I'm on a 10-core Skylake X now. I'm going to be moving to an 18-core.
Yep.
And I already have picked out a new cooler. I'm moving from a dual 140 millimeter setup to a triple radiator external.
Yeah, and that's definitely, and that does pay dividends, because I will say from an overclocking pursuit, we have also found in our own testing, and I'm sure you guys have probably seen something, that thermals do play into the stability. If I can keep that part cooler, I can generally have better overall stability. So sometimes it's not just about helping to make sure that you're staying in a comfortable thermal envelope, but if you can also bring down that temperature, you do sometimes have an improved probability of being a little bit more aggressive at the clock frequency pursuits. And so the other part that we'll add to that is that with X299, one thing that we have seen is that the trend to go with a lot of high performance closed loop water cooling solution. So this is actually Silverstone's Tundra, which is a very nice 240 millimeter closed loop cooling solution. But you're at a little bit of a disadvantage with these in that they do a great job. This one can comfortably cool this processor, no issues, even with a fairly moderate overclock. But you don't have a lot of airflow for the CPU socket area and for the DRAM. And when you heavily load the DRAM, that's a few watts per every DIMM and that VRM area. So many of our ASUS boards have actually found mounting points directly for the VRM. Another option is actually we recommend for some configurations, you can actually change your fan configuration where traditionally these fans would be set as an exhaust.
Yes.
You can actually turn them around and turn them into an actual intake to blow that cool air directly across the VRM and the memory channels. And we've actually found that that can actually provide a tangible benefit to the stability, especially under heavy load situations. And so that is something that you may want to keep in mind. In this situation, you can actually see that how we have this kind of situation set up is intake here, exhaust there, and then we have cool airflow coming in from these Aska Venom fans that we have set up within the system. So that is something to account for as well when you talk about cooling considerations.
Yeah, especially when you have a liquid-based cooling solution, right? We found in our labs as well, very similar testing, right? The VRMs get very hot because if there's not any airflow over it, they tend to soak up a lot of heat. And so having either a spot cooler or, like you said, a top-mounted fan, just with a little bit of airflow.
A little bit of airflow goes a long way there. Yeah, you're not talking about massive RPMs. You know, these are only 1,200 RPM, so they're still quiet, but they definitely give us more than enough airflow to make sure that we're maintaining a good thermal stability and consistency. And that goes out to, you know, the overall design too. Like these, we've actually got our DIMM.2 card in here, which is really interesting. If you take a look in there, you'll see that the DIMM, which actually are two Intel 600P, NVMe, we got our SSDs in there. Those are actually vertical as well, because we, instead of having them directly underneath like the graphics card where there is more heat pooling, right? We can keep them thermally isolated. We get more of this cross-directional intake airflow that helps to keep those drives cool, and we can even mount actually fans directly to that DIMM.2 drive to even if we want to add more thermal control there. It's a lot of choices there. So that's also, I think, an inherent benefit. Not a lot of people think about the thermal options that you have within better boards, but that is something that we have. Like we have the ability, we can do temperature input mapping on these systems. So with a high-end CPU like this, definitely you're probably going to have that be the primary heat producer in the system, but sometimes, and actually in many situations, the GPU is actually quite a bit hotter than the CPU. And so in our latest generation of boards, we can actually assign the temperature instead of being CPU-based, GPU-based. So we could have these front intake fans respond to the GPU temperature as opposed to the CPU temperature. But that choice is up to you. We have a lot of different options on, you can go in there and really, to your heart's content, per every single fan, set that up. If we don't have too many more questions, I think we can kind of begin to maybe wrap some of these things up here.
There's two more. And then I want to also talk about your HyperCard as well. So that same analog, it looks like you actually have a fan on that card.
Yeah, because of course when you're talking about those highest performing drives, we don't want thermal throttle to come into play because of course those are going to be very high performing drives you wouldn't want to have in there. You want a high level of performance.
Yeah, correct. I just want to remind users that airflow is critical, especially for M.2 if they're mounted flush rather than ASUS's implementation, which is fantastic by the way. If they are mounted flush, especially underneath the graphics cards, they can throttle very quickly.
Extremely quickly. And that's why you'll find on actually all of our boards, all of them have generally some form of M.2 thermal isolation. We either place in the bottom portion and they have an M.2 heatsink, or they're vertically oriented on the side of the board, or like on our RG board where we've got the M.2 based design.
Okay. And then the last one is a question from Stephen Heim from Facebook. What benefits for current media software and gaming would an 18-core processor provide? I think a lot of folks have that question, right? They're looking at these large core count parts and they're like, well, you know, I only had a 4 or 6 core before and that was adequate. What possibly could I use that would soak up 18 cores worth of computing power?
It just depends really on your workflow. Like I said, if you guys actually check out some content that we did, like I said, with David Dugdale, we went through actually his Premiere workflow.
Yep.
And like I said, even with his previous generation, which he had a 5960X, so already a high, very powerful processor in its own right? I mean, it was 8-core, 16-thread, and it was overclocked with not even the 7980XE, right, but 7960, right? We were able to see in some of his situations actually over 50% improvements in his workflow. So it really just depends on really your usage model, right? But I think the other key benefit of what we've tried to talk about is that this processor and this platform is not just suited towards multi-threaded workloads, but still can offer extremely impressive single-threaded workloads. And this actually gets back to, I think, one follow-up thing that I wanted to talk about on what are some of the key things that people are going to get really when they upgrade from a previous generation, not just a previous, but more traditionally platforms that are probably really common platforms that users might have had. So an example is, you know, you might not necessarily have maybe people, there might be definitely people that are coming from X99, but what happens if you're coming from X79 or even X58, or maybe you're in that Z77 or Z87 era, right? I mean, you could be shifting over and you're getting huge in performance in single thread. You're getting multi-thread performance. You're getting PCI 3.0. You're getting NVMe. You're getting USB 3.1 Gen 2 support, right? You're getting so many other functions and features. So I think you want to first look and see what is your usage model, what is your workflow, and what's the platform you're on. Because even when you take a look at some of these benchmarks or some of the reviews that are out there, they won't always paint a direct comparison to the platform you might have, right? Yep. Hey, if you've got Z270, then of course these benchmarks might hold 100% true and might be very visible in terms of saying this is the performance uplift that you get. But even then, unless they're testing the exact applications that you are, which many of them are synthetic and they're not the real world application, it might not be a complete indicator of the performance increase that you're going to get.
Yeah, and other things that we're talking about too, and I'm going to use the key marketing word here is megatasking, right? We had multitasking before, and I guess that's cliche now, so now we're using megatasking. But one of the other things that folks are doing, it's a usage model more and more apropos to the internet, is to live stream games, right? To have their Twitch and then to have some other picture in a picture and then a bunch of other options going on while you're gaming. Yeah. And to do that, right? Most games are optimized for 4-core. They're console ports or something else, right? And then you have all the other overhead of encoding and doing your Twitch stream and other items that build on that. Yep. And so having that extra headroom from the processors can help in that gaming aspect. But then going back to your media software, I have a coworker, his sole job, I think, is to spend a lot of money on cameras. But he's enabling a lot of the new media software that's out there for content creation. And he just dumped his, I don't know what it was, insane 512 gigabyte card off of his camera, and it just dumped it into Lightroom. Yeah. And to have his Broadwell, which was overclocked, which was on the X99 system, to do the initial processing for it took 3 hours. Yeah, yeah. Right, 3 hours. And so by having 18 cores versus 10, and that's going to be using a combination of single and multi-threaded, that time could be drastically cut. And so for those folks that have professional photography businesses, or for those folks out there that are creating 3D renders or models, having all of these cores or CAD work, all of these cores are going to really help speed those processes up. And if that equals dollars for you, and
it's a definite, it's a return on your investment.
Huge return on investment.
Yeah, and I will say that there are even still games. I'm a huge RTS guy and strategy guy. If you take even at some newer games, they're finally starting to go in this, and we're seeing the shift for DX12 and things like this. You take a look at like a Total Warhammer. and even Total Warhammer 2, I expect to be the same because there's a basis in the engine. That game actually loves threads, and it's because if you look at the AI, right, it's massive amounts of unit simulation, right, and they're processing a huge amount of this on the cores. And actually, you saw as you were increasing core counts, you're actually getting increases in performance. So that's not going to be the case for, of course, every single title, but what we are seeing is a trend, right? Yep. And I think the balancing act ultimately is that really the CPU is giving you really that kind of best of both world scenarios. You're going to get great single-threaded performance, but you're going to also get great performance. So when you have to have essentially all those cores be loaded. And then, you know, that third kind of gray area is if you want to take on that overclocking pursuit, you've got even more performance there to be able to take things even further.
Yeah. So hopefully I answered Stephen's question. That's all the questions I have on from the internet side. Okay.
Well, I think that overall gives us a pretty good dive. I think we've covered, you know, quite a bit of aspects. I mean, as always, there's a lot of things that, of course, you know, I'm sure you guys will be able to find out more as you take a look at a lot of the reviews, a lot of the benchmarks, the scores, and there'll be more to continue to come from Intel, from reviewers, from us at ASUS regarding, you know, really this platform and everything that it's offering, and it's really quite impressive. So, you know, hopefully you guys were able to, I think, find out a bit more about really this platform as a whole. Hopefully you've been able to see that it's not just, I think, an amazing CPU architecture and design, but as a whole, as the platform, it's quite impressive and definitely, I think, can offer a wide range of users' benefits, whether you're, you know, like you said, a mega tasker, content creator, prosumer, professional. You know, I think there's a right CPU for you in this X299 range. There's a right board for you. And definitely, I think the feature set and functionality, it's a great time for an enthusiast to be able to look at these parts because truly impressive levels of performance and functionality.
Yeah, and I totally concur. And for those enthusiasts that are out there, we do take your feedback seriously. I'm on a lot of the forums. I kind of hide and lurk, but I do read. And a lot of those ideas will filter into our future products. I think Ryan Reynolds is very fond of saying maximum effort, and we try to give maximum effort to the enthusiast segment. And so we do pay attention to your feedback. Please keep your feedback coming, good or bad. We do read that, and we try to incorporate that in our future generations of products.
Yeah, so thank you guys for tuning into the stream. Hopefully you guys found it interesting. As always, if you guys want to see more of these type of streams, you guys can definitely mash that like button. Make sure to subscribe to get notified as more content comes out here from Newegg Studios. For us here, ASUS, myself, it was fantastic to be able to join Aaron and Intel to really be able to kick off this second wave for the X299 platform as a whole, be able to show you guys some really awesome, amazing performance, talk about these new processors, and really, I think, really from top to bottom, a lot of these improvements that have really been baked in to offer PC DIY enthusiasts just an amazing platform. So with that, thank you guys for tuning in. As always, take care, take it easy, and enjoy the rest of your day.